Okay, so yesterday we started looking at cosine law, right? And so the cosine law, we proved it yesterday, where it's a side squared is equal to another side squared plus another side squared minus 2 times both of those sides cos of the angle on the opposite equal side, right? So it's either a squared equals b squared plus c squared minus 2bc cos a, stuff like that. The hardest part about this equation, you guys, is to follow order of operations when you know all three sides and you're solving for an angle. That's where the mistake is made. So the mistake isn't made when you have an angle in between two sides. Why? Because all you did to solve was type it all straight into your calculator, right? And then hit the square root of your answer. So if you know the angle and two sides that are surrounding that angle, it's really easy to solve using the cosine law. Do you agree? Okay. The mistakes come in when we are given three sides. So we're going to look at the three-side question right away here. And so if you look here, we got triangle LMN. And it says, determine the angle measure of M. Okay? So we want to find angle M. So that is this angle right there. Oh, okay. That angle up there. So remember, whenever you do this, the side length that's on the other side of the equal sign is across from the angle that you want to know about or that you have, right? So I'm going to say m squared is equal to L squared plus N squared minus 2ln cos of M. Okay? So what I did was I took all the ABCs and I made it into this triangle. Okay? You could leave it as a squared plus b squared minus 2ab cos c. That's fine. Okay? How did I decide where they went? I looked at the angle we were looking to solve for. That's the side length on the other side of the equal sign. And then the angle that I'm looking for, that's what the angle I actually put in. Okay? Then we just substitute in. So what goes in for m squared? 10. So 10 squared is equal to L squared. What's L? 7 plus N squared. N is 6 squared minus 2 times L times N cos of M. Okay. What would you guys do next? Yeah, you deal with the exponents, right? You get rid of those. So 10 squared is 100 is equal to 7 squared, which is 49, plus 6 squared, which is 36, minus 2 times 7 times 6. 7 times 6 is 42, times 2 is 84. So minus 84 cos M. Okay. Now what would you do? Okay. Oh, he just said the error that everyone makes. Okay. He said, now, I'm just saying, he said 49 plus 36 minus 84. Okay. Why is that wrong? Because there's an 84 multiplying the cosine, so we can't touch that 84. However, we can do the 49 plus 36, so he was partly right. He's like, we got to combine these, make them smaller, but you got to be careful. You can't touch this multiplying 84 times cosine. So we get 100 is equal to 49 plus 36, that's 85. 85 minus 84 cos M. I'm just going to scroll this up. Oh, I'm running out of room. Now, what would you do? Good. We got to get M alone. So we got to subtract the 85, so then we have 84 times cos M, right? Because we're trying to get M alone, but we can't combine these because these two are multiplied here, right? So we'll subtract our 85 to the other side. So when we subtract 85, we get 15 is equal to negative 84 cos m. So we need to divide by negative 84. So when we divide by negative 84, we're going to get some sort of decimal there, right? I don't have my calculator. 15 minus 84, negative 0.1874. Okay. Whatever number you said. Okay. Make sure you write it down. What was it? 0.17857 is equal to what? Cosine. I apologize. I ran out of room. I hope you didn't run out of room. How do you get m? Second cos, right? Which means the inverse of cos, which means on this side, cos to the minus 1, it'll get rid of it and you're just left with m. How do you actually put that into your calculator though? Second cos, second answer, end bracket, enter. You guys are amazing. Okay? What do you get when you do that? Okay? We really only knew to the ones anyway, so 100 degrees would be perfect, right? Now that you knew that angle, could you solve for other angles? You could use the cos law. What else could you use? The sine law, but you'd have to use that 100 decimal, blah, 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 use all those decimals along. Okay. Does he need me, you think, or we'll be good? How about you try and sketch a triangle based on that formula? I'll give you 1 minute. So I was walking around and this is what I saw first. Anything wrong with that? Good. Some people started with their A on the top. It really doesn't matter. Some people will start with their A over there, but as long as you've labeled your triangle ABC, why did you know you needed A? Because there's an A in the equation. I could have wrote MAT, right? Or PAT, as long as I had an A in the triangle. Okay? Now, side length A would be over here. We don't actually know that. Right? What else can we tell about this? One of the sides is 12 and the degree is 70. And that doesn't necessarily mean that C is 12. It could be B, and I'd be happy with either. Okay? So side length 12, angle 70. Why did you know they had to be across from each other? Because they're on the outside of the equation. Remember, whatever matches with this angle is the side length on the other side of the equation. Good. And then it's 7. Perfect. So you can draw a triangle based on that equation. The next question, how would you set this up? Draw a triangle. Good. Label it. Okay, I'm going to start with X on the top because I think I got in trouble last time. So X, Y, Z. Where do I put the numbers? Across from the angle measure. So X equals 12 goes down here. Y equals 15 over here. And Z equals 8 over here. It says solve. Okay? It doesn't tell us how to solve, but it says solve. Can we start with sine law? We don't know one of the total diagonals, right? We don't know an angle and a side length. So we're going to have to start with cosine law, okay? So what angle do you want to solve for? Sure. So side length x squared is equal to y squared plus z squared minus 2yz cos x, right? And we substitute it. So we get 12 squared is equal to 15 squared plus 8 squared minus 2 times 15 times 8 cos x. Everyone's okay with that? Did I mess up somewhere? Okay. So 12 squared is 144 is equal to, now this is how I shorten up some of my stuff. I do 15 squared plus 8 squared right away. 15 squared is 225. 8 squared is 64. 225 plus 64, 289, minus 2 times 15 is 30. 30 times 8, well 8 times 3 is 24. Add the 0, 240 cos x. I do make mathematical mistakes from multiplying in my head, but I find it quicker. So hopefully I didn't make any mistakes. Okay. The other reason why I do the 15 squared plus 8 squared right away, because then I remember that's all I can do on that side, right? I leave the minus 240 cos x by itself. So next step, minus 289 to both sides. And when I do that, 144 minus 289, negative 145. Negative 145 is equal to minus 240 cos x. What are you going to do? Divided by negative 240. Okay. I'm going to just try and pull up my calculator here. Sure. What did you guys end up getting? Where am I? Okay. Say that again. 4604. Oh. Decimal. Am I right? 46? No, that's not right. How would I just use my calculator? My hearing's not very good. Negative 45 divided by negative 240. How come it's not negative, you guys? Because a negative divided by a negative equals positive. So now to solve for angle x, second cos, second answer gives me 52.83. So it's like 53 degrees in our original question, right? So oh, does it ask to the nearest tenth? So 52.8. Now, we just have to figure out one more and then we can do 180 minus, right? Now, some people will choose to do cosine law over again because then you have whole numbers all the way through, okay? Or we can use sine law. Want to use sine law? Okay, so sine law, we know that side length 12 over sine of 52.8, you carry that decimal though, right? is equal to, what angle do we want to solve for? Y. So that's what? 15 over sine y. So when we cross multiply, we get 12 sine y is equal to 15 sine of 52.8. So to get sine y alone, I divide by 12. So I'm just going to pull up my calculator. I have that 52.83, right? So I'm going to go sine of second answer in bracket times it by 15 equals divide by 12. That gives me sine y to be 0.996, right? So how do we solve for y? Second sine, oh, you guys are getting tired of me asking that. Second y, second answer, enter, gives me 84.92 or 84.9, right? So if I come back to the original triangle, angle y is 84.9. That makes sense to me because it's the biggest side length, so it should be the biggest angle, right? How do you solve for angle Z? 180 minus all that. Anyone did that yet? What is it? So 42.24. So it'll be 2. Now, take a look. Does it add up to 180? Okay. So did you round? Did you just go minus 52.8? You did the entire number. You did and it doesn't actually work out to be 180 degrees. So some people, this was 42.4 something. No, what? 42.24. Right. And so what I'm trying to get at, 2.4, it's really close to that 5, so you'll probably round this one up. So you should always double check to make sure that it does add up to 180. So it's just probably when you rounded to that first decimal each time, one rounds up and the other two round down, and it doesn't actually equal to 180. So make it equal to 180, what I'm trying to tell you. We good? Okay, the next two are word problems. I think you can solve via cosine law. I just want to see that we can set up the triangles. Okay, so all we're going to do is set up triangles. If you can get the triangles, you can solve sine and cos. I know you can. Okay, so a pendulum of a grandfather clock is 115 centimeters long. When the pendulum swings from one side to the other, it travels a horizontal distance of 35 centimeters. Determine the angle through which the pendulum swings to the nearest tenth of the degree. It could be, you could put a 90 down the middle and solve. Yeah, solve for each angle. It swings once, but what do you guys know about pendulums? When they, like if you start off this side, it'll swing all the way out to this side, right? And the distance across is that horizontal distance. Have you guys seen pendulums? They just swing back and forth, back and forth. So what do you know about the side lengths of these this triangle? They're equal. They're equal to the length of the pendulum. So it's 115 and this is 115. And this side length down here is 35. My picture does not really reflect what's going on because the 115 side lengths look fairly close to the 35 side length, but that's okay. Now we know it's an isosceles triangle, but we don't know any angles. What angle you're trying to solve for? This angle that the pendulum swings, right? So when you set it up, what would you do? So we'll label this triangle PEN for pendulum. I don't know, something like that. ABC to be really original. What are you trying to solve for? Angle E. So what goes on the other side for the cosine law? 35. So I'll go 35 squared equals 115 squared plus 115 squared minus 2 times 115 times 115 cos of e. Okay? Now, someone says, can we just do this? You probably could, because it's going to be straight horizontal in this case because it's an isosceles one. So you could use this, but you have no other angles. So probably cosine law is the easiest, quickest way to do this. Okay? The last question, because I was just drawing triangles, I know you can do cosine law. A hiker leaves base camp in Banff National Park. He travels north 20 degrees west for 0.7 kilometers. Then the hiker travels south 65 degrees west for 1.3 kilometers. How far is the hiker from the camp to the nearest 10th? So what do you have to do? As the crow flies. Okay? So leaves base camp, travels north 20 degrees west. So I draw a crosshatch there. Northwest is this way, right? On the paper anyway. So north 20 degrees west. This angle. I always mess up when I turn around. I'm sorry. So I probably want to start over here, right? If I'm heading northwest. So this is 20 degrees for 0.7 of a kilometer. Then I travel southwest 65 degrees. So I draw another crosshatch. Southwest is that way, right? Please tell me I'm right this time. So south 65 degrees west. So this angle here is 65, right? Oh, good. We're saying that we've got alternate interior angles because we've got two parallel lines here. This is a parallel line with this one, and so this is 20. So this angle is 20. So we get 85 degrees here. And what do we have? We want to know how far the hiker is from base camp. So we want to know this distance right here. How are you solving for that distance? We have we have that angle, so it's going to be an unknown. So if we label this triangle ABC, you'd say b squared is equal to, and then you'd have the 1.3 squared plus the 0.7 squared minus 2 times 1.3 times 0.7 cos of 85 degrees. And you'd solve for it, right? Hardest part on word problems? Just drawing them out and then putting them into the equations I would hope you're okay with. Okay? And if you're not, call me over and we'll talk. Okay? Now, for some reason, I wasn't ahead of myself and I didn't write out the assignment. So, let's see. No assignment. Let's see. I'm just kidding. There's an assignment. It's not typed out here. So, we're looking at, page 137. You're going to do question 4A, 5A, 7A, 12, and 13. So, let's just type that out. Is that okay? We have roughly 25 minutes. So I'm going to give you about 20 minutes to work on the assignment, 5 minutes for us to talk over the review. I have a few reviews that I have left to mark, okay? Quiz tomorrow.